Okay, happy Saturday, everybody. I hope everyone had a good week. Like I said, and I'll say this for the video right now, this is going to be an office hour style, so I don't have a huge agenda. I am expecting us to kind of go on a little bit of a journey together and let everyone ask questions, however they're going to go. I guess, again, for the record, my name is Nick. I do a lot with Py-Lambdas, but the thing I'm focused on right now is the Code Challenges repository. Last week, I kind of presented that we were rethinking and reformatting it, and then we worked through a challenge together. We're still kind of building challenges for that. If you want to get involved, Brannon currently has a pull request open for like how we are planning to teach functions, like the actual creation of functions to people who are newer to Python. So it's a great place to start. We have a lot of really lower level challenges you can get involved in building. Just to kind of use myself as best as I can, I'm going to be focused on some of the harder or less talked about concepts. And so with that in mind, I'm going to go ahead and share my screen. Does anyone have anything? Actually, did they come with any questions or projects they want to talk about? Okay. Feel free to unmute yourself at any time and stop me if something doesn't make sense. I'm going to go ahead and get a new challenge set up, and then we can kind of go from there. So let me share my screen here. Okay, we'll close that. Okay, I'm already in the Code Challenges repository, and I think, Brannon, do you remember where I said Decorators should go? Did I say 200, 300, or 400?
You said either 200 or 300.
Okay, let's do 200 because I feel like that will make sense. And then just so you guys know, while I'm getting set up here, what we're gonna do is play with Decorators today, because last week Decorators seemed like an interesting light bulb moment for a lot of people, and I had a few conversations where Decorators seemed like something that people knew a little bit but weren't quite super comfortable with. So I've been thinking about them a lot. This is going to be called, in my notes anyway right now, this is called record calls. So I'm just going to say mkdir record calls, and then I'm going to change the directory in there. And then, before I do that, actually, I'm going to activate the virtual environment that I have set up for this. Let's do this. We'll just open it in VS Code because VS Code will do that automatically for me. Okay, in the 200 series, we have record calls, and then in here, we're going to do record calls.py and test record calls .py and whoa, keep up with me, VS Code. And readme.md. I'm not going to put too much in the readme right now. I tend to do that last, so I'm just going to say record calls. Let me look at my notes real quick. And this is just going to be write a decorator function that, what do I have here? That will record the number of times a function is called, and then we'll just hash out bonus one is going to be preserve the name and doc string of the original function. We'll talk about what that is in a second. Bonus two is going to be track the args and quargs of each call. And bonus three is going to be track return value and or any exceptions. I think that'll be it right now. Okay, so this is kind of broadly what we're doing, and let's kind of, I'll talk about what this is going to be. So if you're familiar, or actually I'm going to get rid of function and I'll explain why in a second. So if you're familiar with decorators, and if you're not, you're going to be, because I'm going to be speaking out loud as much as I can. If you're familiar with decorators, a decorator is a higher order function in Python. And Python has some very specific syntax and features when it comes to higher order functions. So we give them like a special name, and they have the little @ symbol name of decorator in order to work. And the way that it works is you define a function, and that function is your decorator. And then inside of that function, you define another function. And that function references the function that the decorator takes, and then allows you to add other features. Some of this we'll get into like how Python memory management works, but basically what we're going to do is we're going to define a decorator. I did not say function here because technically classes can be decorators, and we'll talk about that a little bit more here. We're going to write a decorator that will record the number of times a function is called. So in other words, when you first define a function, the number of calls will be 0. When you first call a function, that number will increment to 1, and on and on and on the number of times that that function is called. The bonus number 1, and I'll show you what this is preserving the name and docstring of the original function. So when you make a decorator, so let's say, let me do this in IPython because it'll be faster. So we'll define a decorator called deco that takes a function, and inside of that we'll define a wrapper that takes args and quargs. Everyone familiar with args and quargs? Does anyone have any questions about that before I go? Okay, cool. We'll take star args and double star quargs, and then we will call the function with args and quargs. We're basically just not doing anything to it. This is a worthless decorator, and then we'll return the wrapper, right? Like we talked about last week, what this actually does in practice behind the scenes when you do like @deco to decorate your thing is you're actually saying like, let's define add, which takes x and y, and return x plus y. And then you're essentially saying add equals deco of add, right? So we're defining a decorator that returns an uncalled function. So when we call deco and we pass it a function, it will return wrapper instead, and wrapper maintains a reference to that function you passed in, which is how the function stays alive even after that original function has executed, right? We then define add, which is this, I feel like people think of defining functions and defining variables as different, but especially in Python, this is not true in every language, but in Python, defining a name is defining a name, or a symbol if you want to get technical. So we're defining an add symbol here the same way we would define like an add variable. And we're saying that that's a function, and then we're changing it. We're like updating the reference the same way that you'd update any variable by saying add equals the deco function, or whatever the deco function returns when we pass it the currently existing add function, okay? What that means is, as we would expect, if we see what add is right now, add is deco wrapper, okay? Now, the cool thing is that add will still work. Or it should work. What just happened? Did I return? I returned x and y. Add 2, 2. Results equals, results is none. Let's troubleshoot this real quick. I return wrapper, star args, double star quargs. I don't return the function from wrapper. So this doesn't return. And all functions return none. Great, so let's redo this a little bit here. We want to return the function, and then let's do add. There we go. And then let's do that. Okay, so add, as you can see, is deco wrapper args quargs, but if we actually call add 2, 2, then we get 4, which is what this function does, right? Now, here's the thing that So this is a useless decorator, like we talked about. The decorators can be really, really cool. And I kind of showed you last week, like we memoized the function so that we could keep track of a cache internally. It's a super great way of handling things, especially expensive calls or like Fibonacci if you want it to be infinitely recursive. Having said that, this is a strong drawback, right? Because if I type add, it actually points to wrapper, and wrapper doesn't actually give me any information about the function, right? If I have like a nice doc string, which everyone knows what a doc string is, right? Is Lambda teaching those? Okay, right. So like if I have this nice doc string here, and we'll just add one, and we'll just say your neighborhood friendly add function. Okay, so if I check add under doc right here, I get that, right? If I check the name for add, then I can see that add takes X and Y, right? If I were to add annotations to add, so let's actually go back and do that because I think this is helpful and interesting. We can say that X is going to be an integer and Y is going to be an integer. If I do add under annotations like that, then I can actually get a dictionary that tells me what those arguments are, right? This is, by the way, how your editor tells you whether or not, like what arguments are and can like lint things for you really, really precisely, okay? So this is super helpful information. And a lot of times in your code, you'll rely on knowing like where a function is located or what its doc string is or what its namespace is. Like I want you to imagine that you are logging what function calls were made in some kind of logging facility, and this being wrong severely affects your ability to understand what's going on. You could have this decorator wrapped around 9 or 10 different functions that all do different things, and if you don't actually have access to the original function signature, the original name, the original annotations, the original doc string, that's going to be really problematic, right? Okay. So, and let me show you what this looks like in like actual, oh my gosh. Let me show you what this looks like in like actual decorator form, just to show you that it does the same thing. So we have our add, oops, there we go. So we have our add function. We're going to say @deco. And again, to explain, we're now doing implicitly what we were doing explicitly. When we add this @ function here, implicitly and invisibly to you, this function is passed as the first argument to this function name. Okay, so it's the same thing as doing add equals deco add. It just lets you do it in one run instead of in having multiple lines where you're defining add 4 or 5 times, right? So we're creating this decorator, we're doing this, and so now add is like wrapper. If we do add under annotations, it's going to be empty. If we add doc string, it has no doc string, right? This is bad. We have no information about our add function anymore, and unless we're looking at the module, or unless the person wrote really good documentation, which all of you have written code long enough to know that a lot of people don't, then we've got some problems. We have no help at all. This is one of those things. This will probably be a hint more than anything that just kind of gives you the answer, but I also want to test your Google ability when it comes to solving some of these challenges. The solution to this is in the functools module. Okay, so there are a couple ways we could do this. The first is we could manually do it, which is a lot of work and kind of a pain. And what it does is essentially you down here you would say like wrapper dot doc string, or is it just doc? It's under doc equals fn dot doc, right? And you'd have to do that for every single attribute you want to override. Okay, but that is a pain, and it makes your code messy, and it doesn't actually increase any readability. So Python, being the wonderful language and community that it is, has given you some tools. So if you import functools, and I'll pull functools up here. Okay, Python functools. It's definitely been visited before because I review it like every day or so. And then inside of functools, there's this thing called wraps. So this is a decorator itself, which is fun because it means that we get multiple decorators. But this is a convenience function for invoking update wrapper as a function decorator when defining a wrapper function. So you can see here that we have this decorator that they've made, which is basically the same decorator that we've been working with. But inside of here, we say that we decorate the wrapper function and say that it wraps the function that we pass into the decorator. Okay, and what that does for us automatically is it makes sure that name and doc and everything that can be updated is automatically updated. So we get to preserve all of those doc strings and annotations, but we still get the benefit of decorators. We kind of get the best of both worlds. Again, this is something you can do manually. There's no magic here, but if you don't have to, then don't. So what we can do to preserve those things is we can import functools, and then we can say, and we'll just save time here. Inside of our deco, we'll say that at functools.wraps fn, like that, and enter. And then we will decorate our add function once more. And now add under name is add, which is what we want it to be. If we look at add, we get that nice function signature that we've had before. We do add under doc, we get doc. Now, there is a corner case here that will be important, I think, in this challenge. If I run help add, oh, they fixed it. Oh, this used to not work. So for a while there, when you ran something into help, it would always return the docs, it would always return the doc string of the decorator. So everything else would work except the help function. I'm really glad that they fixed this. Let me try one more thing. Import PyDoc. And PyDoc is a documentation renderer for your doc strings. If you're unaware of that, you don't actually need Sphinx. You can just use PyDoc. And I'm going to pull my notes up because I can never, ever remember what the exact call is. Render doc. Okay. And we do pydoc.render doc add. Yeah, great. Yeah, it definitely works all the way down. Cool. So that should be fine. This is what the render doc function will return. So it'll return like the location of your function and its function signature, and then any doc string that's involved there. So if you need a lightweight documentation thing, it's good. If you notice, just as a hint or as a help for people who are kind of thinking about adding challenges, all of these things I just checked are really good tests. So if we're writing tests to check whether someone has decorated a function correctly, and we want to make sure that they're preserving the name and stuff, we can essentially just add assert checks for all of these things. And we'll get there eventually. This is a bonus. I just wanted to make sure that that was understood, because that's going to be a bonus that I implement pretty quickly. These other bonuses here, track the args and kwargs of each call. There are 4 or 5 ways to do that, so we'll get there. But essentially, we want to make sure that for every argument passed into the function, to the decorated function, those are stored somewhere, like think a dictionary or something like that, or a list. And then track the return value and any exceptions. This is going to be fun because essentially what I've just said is like when your function returns something, you should be able to access that. So the idea would be that in our add function, if we had add 2, 2, and we'll say results equals, then somewhere later in my code, I should be able to call results.return value and get the return value again. This is kind of meaningless because like, why not? But ultimately I should also be able to say like result calls, let's say the first time it was called, and then we'll get the args like that, or the kwargs like that. And I should be able to turn, at least this is the way that I'm envisioning the API. And there will be examples. I'm not expecting people to read my mind on this. I just want you to be able to follow along as I start writing things. Does anyone have any questions before I continue and start writing tests? Is everyone keeping up with me okay? Have I blown anyone's mind? Okay. So I'm not always a TDD guy, but on code challenges, I tend to at least move that way a little bit, mostly because it forces me to think about exactly how I want the thing to behave before I define it. And also, it means that, you know, I tend to gravitate toward challenges that have 2 or 3 legitimate solutions, but like one ideal one, we'll say. So we're going to import unit test because we don't use PyTest for code challenges. If name equals main, then we're going to call unit test.main. Verbosity is 2, just because I think that makes things nice and pretty. And then we're going to say from record calls, import record calls. And that means we're going to, for now, just create a stub function so that our code doesn't scream at me. And then we're gonna say class test record calls, which is a unit test dot test case. Do I need any setup? I don't think so. We'll just do this docstring here, tests for record calls decorator. And we're going to pass for now so I can gather my thoughts. Okay, so does anyone, based on what we've described here, and I'll put this README over on the side so that it is visible. There we go. Based on this, and I'll add some behavior lists here so I make sure to call it out. Record calls dot call count should start at 0. Oh, what else should be? Actually, this is a commonly failed one. Decorated function should not be called at, is it instant? Is it a decoration time or instantiation time? We'll call it decoration time just for clarity. At decoration time, and we're also going to say that the function should be callable more than once. A couple of words on these. Why I know to test for these is basically because I've been writing Python for 5 or 6 years at this point, and I have screwed all of these up when trying to define decorators. When in doubt, any mistake you make should be a test. You should just keep those with you forever and like learn them over time. I'm gonna try and there we go. Okay. Does anyone have any question about like where I'm getting these from at this point, or are we okay for me to like start writing some tests for these just to kind of get started? Okay. So the first one we're gonna test, we'll say def test call count starts at 0, which takes self and nothing else. And we're going to define a function here. So we'll say, actually, we don't even need to define a function. So we'll use a lambda function. We'll say decorated fn equals record calls lambda. Can I just return none from a lambda? Let's find out. Yeah, great. Okay. So we're passing it, instead of having like to define an inner function, which we'll have to do eventually. Sorry, 1 second. Instead of like defining another inner function and having to deal with that later, we're just manually calling the decorator and passing it a lambda function that does nothing. We'd call it a no-op if you want like fancy parlance, but every time you call this function, it just returns none. And then we want to self.assert equal that decorated fn.call count is 0. That should work. So we'll just say the initial state of fn.call count should be 0. And I'm gonna run the tests even though I know it's not gonna do anything but fail, because why not? Come on, VS Code, I love you. Okay. CD200 record calls. We'll do Python test record calls. Okay, cool. So it takes 0 positional arguments, but 1 was given, which makes sense because we don't have anything here. So let's say fn, and let's get a more interesting. Okay, that still fails. So none type object has no attribute call count, right? We're returning none. We've done nothing to the function, and therefore we have no call count. Oh, someone's joining. Hello. No? Rufai? Can you hear me? All right. Assuming you can hear me for half a second and maybe are having problems with your microphone, we are currently building a code challenge, but today is an office hours, so you are more than welcome to unmute yourself, and like we'll pause this and answer whatever question you have. The one disclaimer I gave them is obviously I'm not an expert in everything. I have some really deep Python knowledge, and I have some really deep Django knowledge and some tangential knowledge about a lot of other things. I work for Heroku, so I have like web infrastructure knowledge and like DevOps knowledge if you have anything on that order. But as you leave the Python universe, my knowledge is going to start to diminish pretty quick. So anyways, just wanted to cover that real quick. So now we have none type object has no attribute call count. Great. So we're testing what we think we're testing, and that's great. So that marks this one. Let's make this a checkbox, and we'll say that that's done. Let's just use VS Code because I actually know how to use VS Code, and that's great. Okay. Yep. Okay, that'll give us what we need there. Let's write another test real quick now that we've got that one done. So we'll say def start with test Nick. There we go. Test decorated fn not called at deco time, just to save me some writing. When the decorated function is defined, it should not be immediately called. So we'll say, I'm going to change this to decorated because that's annoying me to type the _fn already. So we'll say decorated equals record calls, and let's actually define, we'll say def, I guess we'll just do add because that's an easy thing to do. Oh, actually, no. Okay, testing question for you. What is a good way, do you think, to test whether a function has been called? Right, there's like 5 or 6 right answers to this, but I want to hear if any of you can, like off the top of your head, think of what a proxy for that might be. Okay, if you don't know, you can throw any answer you want out, right? If you're writing tests and you want to say this function has been called or this function has not been called, right? Because technically speaking, if I'm remembering correctly, there is not a excuse me. There is not a has not been called in the unit test library. Brandon, I know you're Googling right now, or at least I think you are. You can tell me if that's not true.
No, but I am looking at line 14.
At line 14? Oh, yep.
Yeah, you have to change that.
Good call. Thank you. So I'm just going to say def my func for now. And I'm going to pass, and we'll pass this to my func. So I think guesswork is a super great way to learn things. So how can we test whether this function has been called or not? Or actually, better yet, because it's harder to prove a negative than a positive, right? How can we test and ensure that this function has not been called?
With a Boolean set to false?
With a which?
With a Boolean set to false.
Okay, so we can return false, yeah? Right? Is that what you're saying?
So I'm saying like my funct dot has been called equals false.
Okay, but we're okay, that is a weighted. Does has been called return false? This is actually something I'm not sure of. Let's open unit test. I might be making this more complicated than I thought I would need to. Has assert assert methods. Skip to the list of assert methods. Not an instance. Assert raises, assert warns, assert logs. Almost equal. Multi-line sequence list tuple. Isolated async IO. Oh Lord, I can't even imagine testing async IO. Okay. Raises. Come on now. Oh, am I making up has been called? Is that a jest thing that I'm?
No, you're not making it up. I actually hadn't, I wasn't thinking in terms of assert. I was just saying my funct dot has been called equals false. So it would be,
Okay, so if we do my func dot has been called equals false, right? Like that? Oops.
yeah, single quote. I mean, a single equals.
Single equals. Okay, but how, I guess, how does that
Well,
check
now-
whether my func has been called?
In the function, we can set it to true.
Right.
Okay, so we'll
Maybe.
say dot has been called equals true. Like that?
Yep.
You don't worry about scope with that though at all?
I was gonna say, is that accessible outside? So let's actually do this in IPython real quick. So we'll say def my, and honestly, if you guys teach me something here, that's gonna be awesome because I don't think this will work, but let's find out. My func dot has been called equals true. Oh, actually, I know why my brain is telling me that this won't work, but let's so let's say my func dot has been called. Okay, so my func has no object, so let's call it my func. We'll just do that. Okay, and then let's check if my func has that attribute again. Okay, it does. We can check true. So we can set that attribute like this.
Was it false to start with though? Or-
So it didn't exist to start with.
okay, so just
right.
like it existed all. Okay.
Right. So let's quit this and then start with a new REPL to make things easier. And we'll say def my func like that, and we'll say my func dot has been called is equal to true. and then we'll say my func dot has been called equals false. Okay, so here's my question just logically from this. Let's assume we have a decorator here, or actually, let's not assume, let's show you. So we'll say def deco, which takes a function, and then def wrapper, which we're just gonna take, we're not even gonna take that because we don't need any arguments for that function. And we'll say fn call, we need to return that because I don't want to make the same mistake twice. And then we'll return wrapper. Okay, so that's the decorator. And then we'll say at deco def my, sorry, 1 second. Def wrapper, we can actually get rid of that. We're just going to return the function directly. So technically speaking, this is still going to work as a decorator, or at least using the decorator syntax, because we're still going to pass the function into deco, and then it will be immediately called. Okay, so then we can say def my, we'll add the at deco thing, and we'll say at deco, and let's make sure that this works the way my brain thinks it is. So if we say my func dot has been called, that none type object has no attribute. What is my func currently? Oh, this is gonna be, I'm returning fn, and fn returns none, and then the object goes away because it's inside of another function, so scoping becomes a problem. So I guess rather than showing you, let me just say this. So if I'm going to decorate this function, so I'm going to say record calls like this. And then let's say that it does call the function, and somehow like that function returns has been called equals true. I'm setting it to false. So in other words, if I'm doing that, I know it's going to be true. The way that I would do this personally is I would just say, because what's going to happen if the function is actually called by the decorator? Right.
So if it's ever called, it'll raise an error.
It'll raise an error, which will fail the test, right? And it'll fail the test with the error. So we don't need to do any like magic. We don't need to do any like random dot syntax. We don't need to do any like hard to read things. We just go like, look, this function always returns an error. We're going to decorate that function. If the error gets thrown, you failed the test. Right? Cool. I'm going to, for the record though, I'm going to play around more with that has been called Boolean thing, because that's just like, it doesn't feel like it would make sense to me, but it also did some behavior that I like wasn't counting on a second ago. So that's an interesting suggestion that I might look into. Okay, so let's say def, we did this one. So the next thing we need to check is that the function should be callable more than once. So we're already testing that it hasn't been called. Now we need to test that we can call it as many times as we want, right? So we'll say that def test function still callable, which takes self. And let's just keep using my func. So we'll say def, how do we want to do this? Because I want to check that it's still calling new every time. We'll say calls equals an empty list. We'll say def my func, and then my func does calls dot append call, like that. And then under that, we will say, we'll decorate it. So the decorated function is record, not reset warnings, record calls, my func, and then we're going to say we're going to call decorated, and then we're going to say that self dot assert equal the len of calls should be 1, and then call decorated again, and then self dot assert equal the len of calls should be 2. Right? I'm thinking about that correctly. Anyone want to call me call me out on like not thinking about what that's going to do correctly? Yes, I think that should be fine. Okay, and then let's oh, you know what? I know what we should add because I made this mistake literally in front of you this morning. We're going to, the function should return the value of the decorated function.
Oh, and I just realized that the way that we had the has been called thing set up, I don't think that would work because it would be, we would need the wrapper to have
it. Right, exactly. Which technically would work. Like we could defer that, like that would not necessarily be bad, but it would mean from a testing perspective that we would need to alter their code in test, which is like a huge no-no. Or we would need to like make a stipulation that they add a has been called thing, which again is coupling your implementation and your testing a little too closely, right? Like if you notice, all of these tests are going to fail. I'm defining how I want the function to behave, but I'm not like defining or making any claims on like what function it should be decorating, or even whether it's a function or a class. All of this will still work with decorated classes. And we can talk about what that looks like, because I think sometimes those are easier to understand, but there's just one thing that they fail at pretty hard. Okay, so we'll say def test. Yeah, we'll just call it test return value, because I'm going to be doing other stuff with return values later. Okay, so let's say that add xy, and we're just going to do this in one line. Even though pep8 is going to yell at me, I don't care. And we'll say that 4 equals add 2. Oh wait, no, we need to decorate it. Shoot. Add equals record calls add. 4 equals add 2, and then self dot assert equal 4 and 4. Okay. Yeah, I knew Pepe was going to yell at me. All right, fine, whatever. Okay, and then oh, I guess the main thing that we should test, and I can't believe I didn't write this down, is the fn.call count number should monotonically increment from 0. I mostly wrote it that way because I like the word monotonically, don't at me. And also the single most cursed code comment I've ever read in my life. So as you know, up at the Python level, things are like wonderful and clear and everything seems normal and computers seem really, really smart. And then like, as you get into deeper systems languages, that starts to go away until you eventually get to electronics and like everything is just the fact that we cursed sand with thinking and now we deserve what we get. And so the worst comment I've ever seen is in the time like code for Rust. There is a comment that just says, the assumption of most computing languages is that time moves monotonically forward, meaning like seconds go forward, but that isn't actually true on every piece of hardware. like time does not always move forward second by second, which causes all kinds of bugs. So like they had to do all of this like really crazy like code to get around that, to make sure that they can like rely on like Unix epoch time. Anyways, computers are hard, and you know, everyone is struggling. That's really what we're going to talk about. Okay, so we'll say def test call count increments from 0. Just take self, and I think this is the last test we'll write, and then we'll write some code and have a little more fun than we're having right now. So we can do this with a no op. So we'll say decorated equals record calls lambda none. And then we will say self.assert. So let's assert that it starts at 0. So we'll say decorated.call count is 0. Nope, not minus 0. There we go. Then we'll call it, and we'll say self.assert equal decorated.call count is 1. And then just to make sure nothing fishy is going on, we'll do it one more time. Self.assert equal decorated.call count is 2. Okay, I have not been adding doc strings this entire time. I will have to go back and do that because I don't feel like making you watch me do that right now. Okay, so we're testing that the call count increments. We're testing that the return value from the original function is actually returned. We're testing that the function is callable as many times as we need it to be and always returns what it should. We're testing that the decorated function is not called, and we are testing that the call count starts at 0. Oh, I guess, hold on, I'm glad we did that. I don't actually need that initial test because we are already testing that the call count starts at 0. Boom. That's why it's always good to read your own code. Okay. Is there anything I'm missing? Can y'all think of something that we would need to test from like an initial implementation of this function? Oh, I might have something, but I might have one thing precisely, but I'm gonna let y'all think for a second. So did everyone, Heather, you went through data science, right? No, you went through web?
Yeah, web.
Okay, did everyone go through web? Perfect, this is gonna be great. So when they taught you closures in JavaScript, which would have been like, I think week 3 of JavaScript, okay? And I know talking about JavaScript in a Python thing is like terrible and we should never do it. But when they taught it to you, they had you create a counter, right? When they were trying to teach you closures. What happened if you implemented your closure incorrectly? This was worlds ago for me and probably for you, but I just teach closures a lot. And so this is something I'm familiar with. If you're not thinking about it, it's fine. But like, let's say, for example, we instantiate 2 counters and the closure is not implemented correctly. And then we increment the first counter and then we increment the second counter. What could go wrong?
Incremented? Is that what you're thinking?
Right. Yeah, right. We want to make sure that if we've got 2 instances of a decorated function, that the call count is not the same.
That's independent. Yeah. Okay.
Yeah. Okay. Okay. So def test multiple call counts. We'll just call that. And we will say we'll do the same decorated function equals record calls lambda none. Actually, because if I need to test multiple instantiations of it,
Maybe like a 1
I
and 2.
should, yeah, I should do 1 and 2.
Or something like that.
Yeah, so we'll do fn1 and we'll do fn2 record calls lambda none. Okay, and we'll say we know that we've now tested multiple times that they increase. We've tested multiple times that they start at 0. So now we just need to test that they're individual. So we'll say fn1, we'll just call it, and we'll self.assert equal that fn1.callCount is 1, but that fn2.callCount is still 0. And then we will, or actually, let's be smarter about this. Let's do that. We just need to assert that we haven't done anything to fn2 call count. And then if we want to be particularly interesting about this, we can say that fn2 will call that twice, and self.assert equal fn1.callCount is 1. Great. Okay, that is the call count should be separate for each decorated function. Okay, so we've got that. We've got these working. I'm going to run the test real quick, and all of them are going to fail. Yep, so none type is not callable. So it's just going to give me none type is not callable. Everything is failing either in an error or when the decorated function is defined, it should not be called. That is currently okay. And it's because our decorator does nothing. Great. Okay. Cool. So now we have this stub function. So I guess I will ask a question as I am like trying to build my own implementation for this. Excuse me. What? Oh man. Whew. Do you want to see a function decorator, which we've been working with a lot, or do you want to see a class decorator just to see how that looks? I can do either. I just want to know what would be more interesting to y'all.
I'm working more with not the class decorator. So if you want to keep going in line with that one, that'd be fine.
Cool.
Maybe if we have time, maybe do a class one at another time.
Yeah, absolutely. Okay, so let's do this. We'll do def. So actually, I don't know why I erased that. Okay, so that takes a function. And then just for like sanity, conventionally, I like to call my decorator wrapper. That's what most of the docs are going to refer to inner functions as. So like anything you can do to lower your own cognitive load is like a solid way of doing things. And then we're going to call the function with args and quargs. Okay, but we need to increment the call count, right? So we'll do fn.callCount plus equals 1. And then to make sure that that doesn't do anything weird, I'm going to say, nope, not wrapper, fn.callCount equals 0, return wrapper. That should do what I want it to do. I'm not returning this though, so I'm going to return this. Okay, does everyone understand what I'm doing here? Okay, I could put this fn call count in front of wrapper and then just leave the return wrapper on the line below. I could see it go either way. I tend to like my function definition to be the first thing there, unless the thing I'm creating is a cache. There is absolutely no logic to that decision. It just is how my brain likes to look at things. But anyway, so we're defining this thing. We're gonna increment the call count by 1 every time it comes in, and then we're gonna return the function. We're gonna start the function call count at 0, so that attribute will exist on the function object. before wrapper ever gets called. And then we're going to return wrapper. Pop quiz, since we've been talking about functions a lot, we call this function. Why does wrapper still have access to it after record calls has finished executing, right? Because generally scope wise, anything that's a local scope would go away. So why is it still in memory? Why is it still accessible by wrapper?
Wait, because we're creating closure.
Well, okay. Yes. But why? Okay, so let me ask a different question that is related, but slightly, or I guess it's kind of the answer, but it's slightly low level. How does Python's garbage collector know when a piece of memory can be reclaimed?
When there's no reference count to it, or if there's like circular references.
Exactly, right. So the way that Python's memory works is via reference counting, right? So variables are references, they just point to values. If you say a equals 1, then the integer 1 gets put into memory, and a is a pointer to that memory address, okay? And then the garbage collector stores the add name and increments that particular memory address. It increments the references to that address to 1. If we then run del A, that memory reference gets decremented to 0, and the garbage collector marks that piece of memory as reclaimable. Okay, so when we define wrapper, we don't call wrapper, but because inside of wrapper is a reference to something outside of wrapper, then using Python's LEGB scope, right? Local enclosing global, what is B? Built-ins, there we go. And using the LEGB scope, it looks at local for FN and it goes, okay, there's nothing in like local to the wrapper function that is FN. And then it goes to the enclosing scope, which is the local scope of record calls. And it goes, oh, found FN, which means that is now stuck in memory. It now has a reference count that won't go away unless you delete the wrapper function from memory, right? That reference count will always stay. As a result, FN gets to stay in memory. We can work with it. We can leave it long-lived. It'll, the like record calls dot locals will keep being able to reference all of its local variables kind of forever, which can cause a memory leak. But for now, we're doing it on purpose. We're creating a purposeful memory leak. Anyways, I like to, if you haven't noticed about my teaching style, I think knowing a lot of the underlying foundational stuff of like what Python's doing in the background helps make the syntactic sugar you get up top less like magic. And therefore it's easier later on down the line for you to go, oh, I know what that's doing, and then you can manipulate it. I had a professor, I was in the music industry for a while, so I had an audio engineering professor, and he used to say, you need to really know what the rules are so that when you break them, you know why. Right? You're going to break the rules. You're going to manipulate the code to do whatever you need to do. Knowing the rules isn't a way of making sure you stay in bounds. It's a way of making sure that you know when you're breaking a rule and why you're breaking a rule. Right? So in this case, we're breaking a rule that says you shouldn't have long-lived memory that just kind of keeps being mutable and adding on over time, but we're breaking it on purpose to give us decorations and like all these other features. Neither here nor there. Okay, so with this, we have record calls, don't want to do that. We have wrapper, we're gonna increment the call count every time it's called, and we're going to, start that call count at 0. I have one philosophical question for you. Should I increment the call count before I call the function?
I was wondering
or should I?
Yeah.
Yeah. So there's no right answer to this. I kind of want to know I have an opinion, obviously, and some of the bonuses might indicate that opinion. But I guess what do you think? Like, what would your preference be if you were writing this?
Logically, I think it makes more sense to flip that, but yeah, it's one of those things where there's no clear answer necessarily.
I agree with that, because the function call could fail, right? We could like raise an error or something in there.
But it would still be called as far as what you're saying, Brandon. But
yeah, I guess that's true.
But it just like hasn't, like, timeline hasn't happened yet, or
So
if
let
count
me.
out was not like incremented, right, or is not like implemented, right? Like if you didn't have that line 6.
Yeah. So let me ask you a question on this, because some people don't actually know how this works, or at least I didn't for a really long time. So if we do this and then we increment that and we say return result, right? So we're calling function above incrementing the call count. What happens if fn throws an error? Does this code run at all?
Oh no, yeah, probably
Right.
not. Yeah.
Right. The error, like if you're unaware, the error actually freezes execution in time, like in the runtime, and then it bubbles up and exits the program unless you catch it and do a bunch of other things, right? But we can have no idea. We can't put this in a try catch block really without just catching everything, because we have no idea what this function is going to be doing. So I agree with you. And my instinct when I was thinking about this last night on the whiteboard, my instinct was to increment call count after, because I like to fail closed. It's like the #1 thing that I like remind myself all the time. And if you're unfamiliar with that terminology, it means like, let's say you're building a login function. If something's going to break on login, do you fail and let them in the front door, or do you fail and close the door and make their life miserable? The answer to that question is you fail and close the door. Right? You don't log them in, you don't send them the token, you do everything in your power to make sure that if login is broken, that means no one can log in instead of everyone can log in, right? So in the same way, I would tend to philosophically like want to fail closed here and say, if the function returns an error, or I guess if the function returns an error, like or I want to make sure the function actually gets called before incrementing, right? In case something goes wrong somehow between incrementing the call and actually calling the function, like I hit a keyboard escape or whatever. However, this is actually what led to this bonus here. The reason that we're tracking exceptions is because I want the call count to still be incremented and recorded, even if the function throws an error, because that is useful information to have. And so as a result, I end up doing this in the initial implementation. But I wanted to talk about it because, one, I think it's definitely noticeable that you'd be like, well, hold on, what if something happens? And then you have to kind of follow that train of thought down the road. So anyways, hope that was at least interesting. Let's run our test. Let's see where we're at. So we'll test record calls. Okay. So function has no attribute call count. Interesting. Is it supposed to be wrapper call count? Oh, it is supposed to be wrapper call count. Right? Because what do we interact with outside? Right? Decorators are hard. You have to like break what you're thinking about what you're working with a little bit. Okay, so the wrapper is what we're going to do that on, and now everything should pass. Great. Okay. Cool. Before we continue on and start talking about bonuses or anything like that, does anyone have any questions about this implementation or anything that they like want to talk about other than what we're working on right now? Like, did something come to you that you've been thinking about for weeks and don't know how to solve? Okay. Cool. Let's go back here. So we need to test a bonus. For those of you who have not, seen the code for the code challenges yet, when we do bonuses, they are always assume that you write the test assuming that the person taking the challenge, the challengee, I guess, I haven't come up with a good word for that yet, because I don't want to call y'all students. Like, I don't think you're students. I think you're professionals. I think you're like learning the same way that everyone is. But the challengee, we'll say, we want to assume that they're not actually going to do the bonus, okay? And in order to do that without annoying them with tests failing, what you can do is use a decorator, and it's unit test.expect failure. And what that means is the next test function you do will still run like a normal test function, but it is expected to fail. And if it fails, it's okay. If they actually implement code and that test succeeds, then it'll actually throw an error. So what we want to do is add a comment, and usually I just kind of have a standard comment that says to test your implementation of bonus 1, comment out the following line. That way, if you comment out this decorator here, then the test will function the way that you expect it to. So now we're going to say def. So the first bonus is preserve the name and doc string of the original function. So we'll say def test preserve name and docs string. Just take self. And do I want to still do the like manual thing I've been doing, or does it benefit me to do it a different way? We'll just do at record calls def add x comma y. We'll just do the whole thing we were doing. And then we will return x plus y. Okay, so now we have a function that is defined. Oh, we need there to be a doc string. Example add function, so that'll let us test some things. So let's just call it now, or do we need to call it? It's already defined. Okay, we'll do self.assert in, and we're going to assert. How does assert in work? I always forget. Ah, okay, it goes thing first. That's why I forget, it always bugs me. Okay, so we're going to assert that add is in add, right? Because if we're not preserving the namespace, then the name is actually going to be wrapper. And let's actually make this easier. We'll say dot dunder name, so that we're explicitly testing the name. And then we will do self.assert in example add function is add dot dunder doc. And then we will do, what else should we test? Let's import.
Right,
Oh,
with
go ahead.
the function too, make sure that.
Say one more time.
Oh, would you try it like adding a different function too to make sure that they don't override each other or something like that? I don't know.
That is not a bad idea. I think in general, well, I guess two things. One, we're testing whether or not they are separate instances in this test above. So my tendency would probably be to not do that. The other reason I would consider not doing that is just from a user experience perspective. So for example, generally speaking, this is kind of an unwritten rule, and it's mostly unwritten because I haven't written good contribution docs yet. But your bonuses should only have one test. It means that they'll be not like traditional unit tests, but from a user experience perspective, if you're a challengee, it means you only have to comment out one line in order to do all of the tests for that particular bonus. So if there are 3 bonuses, there are 3 tests instead of you having kind of,
yeah.
Exactly right. And so you are not wrong, but I think that I think that it, what's it called? You're not wrong, but I think in this case, I might avoid that. Self.assert equal, we'll say, or not equal, whoops. Oh no, yeah, equal, let's do equal. Since we're testing the thing, we'll define a dictionary and we'll say that X, is X the string integer? Am I still here? Let's do this with functools wraps. Import functools. We'll do the functools wraps one, and then we'll do. Man, sometimes I feel like typing might go faster, but you never know. Add dot annotations. Okay, the variable name is the string, but the type is the type. So if I do add if I do add annotations X, I get int. Can I call it? Is it the actual thing? Yeah. Okay, great. So if you don't understand what the heck I'm doing here, so I'm trying to figure out what type the actual value of the annotations dictionary is. And I was trying to figure out if that was the actual like int function or not. And if it is the int function, then this resolves to the value, and then I call the value. So if you're used to functional programming in any way, this would be called like currying to some extent. You're like passing values through other things. But yeah, just a quick test. I just don't like things to not make sense if people are watching. So we'll do, whoa, that's messed up. Don't do that. Okay, we'll do that. X equals int and Y is int. And then that dictionary should be equal to add dot annotations like that. Let's hit save. Okay, and right now that should fail. So if we run tests, oh, it's expected to fail. It did exactly what I told it to, as it turns out. There we go. So let's do that. Okay, great. So that fails, right? So add is not found in wrapper. We fail the first assertion and we hightail it out. The solution to this, if we want to test, should just be import functools. And then inside of that, we're going to say at functools.wraps fn. Hit save. And that should pass. Great. Everything passes. So now, yeah, we've got all of that. So that gets us through bonus 1. Bonus 2, track the args and quargs of each call. Okay. So this on its own is a pretty decent challenge as it stands right now. In general, with bonuses, I like to force people to acknowledge portions of the standard library that they may not know about. So let's say, for example, that in order to figure out the number of calls, right? So like, if I'm going to track the args and quargs of each call, then I need there to be some kind of iterable or sequence where I can access like historical calls. And since the call count increments, I can essentially check that increment number -1 if I use a list to see what the args and quargs are. If that makes sense. So like, let's say that I had like a list, and then every time I called a function like this, the arguments like 1, 2, 3, and the quargs like verbose equals true were added to this list, right? The first function call would be at index 0, the second function call would be at index 1, et cetera, et cetera. But the only thing about this is, let's say that if I wanted to access that, so I say we want to access what the first function call was, and I want to see only the args, and I want to do it like this, right? There are, I think 3 ways that you can do this right now in Python. If you see dot access like this, that means you're looking at a class no matter what. So we'll say the verbose way of doing this would be to say like class call def init, which takes self, it takes args, which is a tuple, and it takes quargs, which is a dict, and we're not going to add like too many things from here. And then we'll say self.args equals args and self.quargs equals quargs, right? So this is totally doable, and that way, like here, we can actually say, excuse me, we can actually say that like call equals call args and quargs, like that. And then outside of, or not outside of here, say calls. How do I want to do this? Oh, I know how. So we have call count, and then we'll say wrapper.calls is an empty list. And then we will say that we want to call wrapper.calls.append call. Okay. That was a lot that I did really, really fast. Does everyone understand what I'm doing here? Okay, great. So this is one way to do it. I don't particularly like this way. And here's why. We're doing a lot of like boilerplate here, and we're also only defining an init. There is a really good talk from several years ago now called Stop Writing Classes. And I highly recommend watching it. It changes a lot of how you can think about like writing your code. But the guy goes on a rant and he goes, classes are great, Python has great classes. But if you're defining a class that only has 2 methods and one of those is a init, then you shouldn't write a class, just write a function. I'm going to, I think by and large, that is a good rule of thumb, right? I'm going to disagree with it slightly because I live in the future where Python 3 has implemented a couple of features that are actually super useful. And one of those features, so there are a couple other ways we could do this. We could do the same thing by doing from collections import named tuple. I don't know if you've seen, has anyone seen named tuple before? Is this totally new to you? Cool, okay. So I'm going to do this here then so that we can play with it. So we'll say from collections import named tuple, like that. And then we'll say, let's say call equals named tuple. And we will say that the name of this is going to be call, and it's going to take a list, and that list is going to be args, comma, quargs, like that. Okay. So I forgot to close that out. Great. Okay. So what this does, what named tuple does, is it gives you something that acts kind of like a class, but under the hood is a tuple. And it gives you access to these, like dot access to these values, right? So the way that you use this named tuple is by saying like call, and then we'll give it 1, 2, 3, like that. And then we'll also give it some quargs. So we'll say verbose equals true, like that. And then when we hit enter, what gets returned is this like call object, right? So we'll say C equals so that we can play with that a little bit. So we'll say C equals, C is that call object, C dot args is 1, 2, 3, and C dot quargs is that verbose true thing. Name tuples are awesome. I highly recommend using them. Like one of the other benefits of them is if we try to say c.args equals 1, it's actually going to fail because it's a tuple, right? So it's immutable. So it gives you this kind of like immutable class that you have to spend almost no time defining. There are a couple of problems here. The first one that I'll say is we don't know what the return value and or the exceptions will be ahead of time. And so we're going to have something that's mutable. And so name tuple doesn't exactly work for our behavior, but I think it's not a bad option. And I also think that they're super cool and people should just know about them. The other thing that works here is data classes, which are brand new. So we could say the way that they work is we say from data classes import data class. There we go. And then we can say class, or actually decorator, sorry, at data class. Then we'll say class call. And then call, we'll just say args is a tuple. And we'll, or actually, I'm going to import some stuff from typing. Yes, that should be it. Okay, so at data class call, and then we'll say that args is a tuple of any number of values. Quargs is a dict, and then return value is any. And right now we'll just have it default to none, like that. And I'll talk about why we don't want to do that later, because yeah, return value is none. And then exception is optional any, and it also equals none. Okay, this is all you have to do to define a data class. And what it will do is it will actually throw an error. Like it gives you mutability, so I can update return value after the fact. Like if I say C equals call, or actually I can go up and do that. Like that, C equals call. So now we have C and we've got all this data here. But I can also update C dot return value to be 1. And now it's there and I have this nice string representation. If I try, let's say C2 equals, this should fail, but I don't know if it fails at runtime or only at like testing. If I just say C1, 2 like that, oops, C2, that should fail. Oh, it doesn't. Okay. In that case, for your editor's sake, all of this does is implement a bunch of behavior for you, and then in your editor tell you what these values should be without enforcing them. I use MyPy by default, so some of my understanding of how types work is a little wrong. If you're unfamiliar with MyPy is a static type checker for Python. So if you use type annotations, it will kind of like TypeScript tell you that you're doing something wrong. But anyways,
I was going to say this reminds me of interfaces in TypeScript where they're into objects, but not quite the same. Yeah.
Exactly. Yeah. So data class is a type of like struct that you can define. And the benefit of this is that it automatically defines the init for you and automatically gives you some behavior. Like, for example, if these were numbers, then it would also automatically give you like a greater than, less than behavior on like certain fields. So it defines a lot of dunder methods for you. Like if we do dir call like that, sorry, dir C, my bad. This is what it gives you like by default. So we get like C dot annotations like that. It gives us all this like nice behavior. We get args, exception, you know, all that fun stuff. Weak ref, which we're not going to get into. Yeah, like all equality, things like that. You can also edit. If we edit data class, we can make it immutable by setting frozen to true. So you can like really quickly get all this like default behavior. Notice like we get this really nice string representation, but we didn't have to define dunder stir or dunder repper, right? So it just kind of saves us a lot of code. The other thing that's really great, if you are familiar with TypeScript or like static typing, is typed dict, which is in the collections module as well. And typed dict lets you define a class like this that inherits from typed dict. And what it will do is if you have a dictionary that's going to have specific values, or like specific attributes, like it's an actual object you're getting from a database or something, you can actually statically type that. And then if you are saying that this function takes this particular type of dictionary, then it will know what values it's supposed to happen. Again, this is Python, so none of that matters at runtime. But most of your time is spent at development. You're not looking at stuff in runtime. So if you use MyPy, it's really, really great. The only thing I'll add to all of this real quick is there is no single module in the standard library that will improve your life more than the collections module. Learn everything you can about things in the collections module. Almost no code challenge I have done since leaving Lambda, and really almost no function I've written on my own in any project has like not used something from the collections module. It is like the shining star of Python, in my opinion. It's super great. I highly recommend it. Take some time with it. So anyways, so we're here. We're going to, let's do a data class, because I think that will solve our problem nicely. So we'll say from data classes, import data class. We're going to make this a data class. It's going to yell at me for a second. Okay. And we'll say self.args, or not self, args is a tuple, quargs is a dict. We don't need return code just yet, but I'm going to add it anyways, or return value, excuse me. Return value is any, and we're going to default it to none. And actually, we're going to talk about, we'll talk about this in a second because it's next. We need to import any. T comes after D, which actually goes above F. So from typing import any and optional. And then we'll say exception is an optional any value, and we're also going to have that equal none right now. That's option, not optional. There we go. So now we call, we add args and quargs, we append to the call, all that fun stuff. Here's something more fun that we can do. We can actually say that result, we can kind of beat a bonus right now. We could say result equals fn. So we'll get whatever the output of that function is, and then we will say, we'll say call dot return value is equal to result, and we will return call dot return value. Here is a Python memory pop quiz for you. So I create call, and then I add call to the list, and then I edit that specific instance of call. Is that going to update the item I put in the list or not?
Can you repeat that, Nick?
Yeah. So here I create a call class, right? And right now it'll only have args and quargs, okay? And then I add that to the calls list, which is this like empty list here, okay? And then after I've already added it to the list, like I'm not referencing the list anywhere here, okay? I get the results of the function that I'm decorating, and then I set this call object's return value to result, okay? My question is, I've already added that call to the list. Will that update the value in that, will that update the return value of the call object in the list? If that still doesn't make sense, I can do a more practical example.
Yeah, the question kind of makes my mind hurt.
Yeah, no, it made my mind hurt a lot. It's totally okay. So this is kind of a question about how Python references work, right? So let's say that L is an empty list like this, and then we're going to do L.append, or actually, We're going to say L2 is an empty list, like that. Okay. And we're going to say L dot append L2. Okay. So now if we look at L is a list within a list. Okay. So now we do L2 dot append 0. So we have added 0. If we look at L2 is now a list with 0 inside of it. My question is that 0 added to the list that's inside of L or not? Right, because we appended L2 to L and then we updated L2. Did L update?
Okay, so the question is, do L and L2 reference the same memory location?
Yes.
And
the same mutable reference location. Sorry, what was your answer?
I'm guessing yes, but I guess
I'm going to say no. Oh, I'm
yes.
wrong.
The answer is yes. So this is very, very important, especially if you're coming from JavaScript, where like most things are passed by value, not passed by reference, right? When you add something to a list, Python does not duplicate the value. So if you still have a reference to that place in memory and you update that thing, it will update everywhere. So like we can do this the other way. If we say that we want to add to the first item in L, we want to append 1, whoa, like that, and then we hit enter, and then we look at L2, L2's been updated, right? They're sharing a single reference.
so I'm betting your original question is that it will update it then.
It will, yeah, exactly. It's one of those things that I think people forget, where they constantly are like, oh, now I have to go back and get that thing, and then I've got to append it, and like, how do I know what index it's going to be? I guess I could use like negative indexing, when the answer is actually like, okay, well, we've never let go of that reference to call, and call is mutable. So we can update call afterwards, and it will still update in the list. It'll have all the values that we want it to have without doing any of that complicated work. But this is just important to know in Python in general, right? If you only have one instance of a thing, then it doesn't matter where that thing is referenced. If you update that thing, it'll update everywhere. I think most of the time, coding challenges do you a disservice by only giving you immutable values, right? So like if we have a list, so we'll just redefine L, like 1, 2, 3, 4, 5, right? Like if I do 1 plus 1, nothing's going to update because integers are immutable. And when you add them together, they return a new integer, right? In the same way, if we do like first value of L and we do plus 1, like L hasn't updated. This is still the same number. We can't even do plus equals because, oh no, that does work. Haha, I found one. So we updated the reference portion, and that mutated the number, right? So these don't mutate, and this one does, right? But this kind of memory stuff in Python can both ruin your life and make your life really easy. You just have to remember exactly what you're working with. By the way, this behavior is what makes tuples so popular. Because if you can have something that is like a list, but that does not in any way get mutated, then you can guarantee there's no memory leak or like any problems of race conditions or things like that down the line. Everyone knows what a race condition is? Did I just use a term that people are unaware of? Okay, so a race condition is, let's say that you have two applications that are both calling the same API, right? One of them says, change my bio to hello world. The other one says, change my bio to I hate this place. They both happen at the same time. Which one wins? The answer to that question is you have no idea, okay? Now, that's an easy one, right? It's gonna happen in whatever order it happens, and you'll wind up with whatever bio that you want. Now I want you to imagine that you have an event trigger on a database update. And that event trigger also updates the database. Okay, so I update a database record to add my name, and then the event trigger updates to change my name, which then triggers the event record, which then changes my name, which then triggers the event record, which then changes my name, which then triggers the event record, which then changes my name. I have created a kind of infinite loop where data is always in a weird state. In databases, and I work on databases a lot, so this is where a lot of my knowledge is. In databases, race conditions are a huge problem. You can get what's called a dirty read, which is, let's say that I'm running an update query at the same time that I'm running a select query. Will my select query get the right information, or will it be the wrong information? The answer to that question is, I have no idea, right? The more technical answer to that is, if you're using Postgres, the Postgres query planner is going to take both of them and then look at what your level of data security is, which the default level allows for dirty reads. And it's just going to give the select thing, like, since select is faster than update, it's going to give select the old information, and then it's going to update the record. If you change your default read security, it will actually do the opposite of that, or it will just throw an error on the select query and let you know that you can't do that, right? Race conditions are super, super important. A lot of times people will like trigger them inadvertently. The big computer science word you want to know about dealing with race conditions, and at least some race conditions and some issues, is you want all of your functions and all of your code to be as idempotent as possible, which is a big word that just means if the function is called more than once on the same piece of data, it will only take action once, right? So if I have a function that updates a text file and converts it to Markdown, the idempotent way to do that would be to first check if it's already a Markdown file, and if it's already a Markdown file, to not do anything. And if it's not a Markdown file, to then convert it, right? So I could call the function to convert things on the same like file over and over and over and over and over again. But if it's already a Markdown file, it's not going to change anything. It's fully idempotent. It'll only do its action once. This gets really important when you start talking about APIs like Slack or Discord. Like, you want all actions as much as possible to be idempotent, because otherwise you can get duplicate messages, or you can get like webhooks that are responding to other webhooks and things like that. With that being said, I've got 5 minutes, so I'm going to finish this up real quick. Okay, so we've got this here. If I'm thinking correctly, track the args and quargs of each value. Did I even write that test yet? I did not. I'm very bad. Okay. So we'll do @unit test.expected failure def test track args and quargs, which will be self. Oh man. Okay, and then that's going to be @record calls def my, or should I just do add? Is there anything I need to test that's yeah, no, I think it should be fine. So we'll do my func star args double star quargs, because I need to be able to test them. Never mind. Double star quargs, and then we'll say return args and quargs. If you've never seen this return signature before, this implicitly returns a tuple where the first item is args and the second item is quargs. So we could wrap this in parentheses, but in Python, you don't put a parenthesis anywhere if you can help it, or really anything anywhere if you can help it. So now let's say self.assert equal, and we'll say that the len of my func.calls is 0, right? Because that's the list, but it should exist. And then we will call my func like that, and I should probably pass it actual. No, let's just check that it's incrementing. Self.assert equal len my func.calls should now be 1, and there should be no values in args and quargs. So that means that args self.assert equal my func.calls 0.args is going to be an empty tuple, and quargs is going to be an empty dictionary, which I'm, just to be explicit, I'm going to do that and that. That's yelling at me because I didn't close that. There we go. Sometimes VS Code's automatic parenthesis closure is the worst. And then let's go, we'll call myfunc this time with arguments. We'll do 1, 2, and then the dictionary, or nope, don't need that, just needs to be, okay. And then we should be able to say that self.assert equal myfunc.calls, calls 1, or nope, sorry, myfunc.calls is equal to 1. We're going to get the length of this. That's what I meant to do. Sometimes my fingers works faster than my brain. Okay, and then we're going to say self.assert equal myfunc.calls 1.args is equal to the tuple 1, 2, and quargs is equal to the dictionary verbose true. I don't think there's anything else I need to test. Is there anything else y'all think I need to test on this one?
No, but I think you forgot a closing parenthesis on line 86.
86.
Oh, maybe. Oh, never mind. Maybe it was just, never mind.
Oh, yeah.
I didn't see it. Sorry.
No, good eye. I didn't see it either until I scrolled over. Great. Okay. Thank you for that. That's super helpful. Okay, cool. I'm going to hit save and let Pep8 do its thing. Great. Hey. Oh, wait. It's currently expected to fail. That's bad. We actually want that to succeed. That doesn't work. Assertion error 2 equals 1. Oh, whoops. That's the second time we've called it. That is a failure of my test. There we go. Okay, that works. So we got args and quargs. Okay, it is technically time right now. I have one more test in order to track. We're already tracking the return value, but in order to track the exception. Is that something people want me to continue doing so they can see, just to like complete this challenge? Or y'all just want to call it?
I want to see it.
See it through to the end. I mean,
Yeah.
if you have
Okay.
time.
Yeah, I have time. I just don't want to. I know that I can monopolize people's time pretty well, so I like to at least try to be respectful. So we'll say unit test. We'll do this the right way this time.
Curious too about why you said that like equals none was going to run into problems.
Yeah. Oh,
The
yeah.
data
Okay.
class.
Good. Yeah. Okay.
This time.
So very, thank you. Very good. So we'll say def test record return value and exceptions, which takes self. And then we're going to say at record calls. There's something else I'm going to do here at some point, but for now, this is going to work. At record calls def myfunc takes, I'm just going to say it's going to take args and quargs. And then I'm going to return the sum of args. So it's going to be a list of integers. And we'll return the sum, and then we'll just return the quargs because I don't want to have Python yell at me. Okay, and then we'll say self.assert equal myfunc. Do I need to call function? I need to call the function first. Myfunc. Self.assert equal myfunc dot calls, and we're going to get the first call. And we're going to say that the return value is equal to right now it's just going to be, oh, actually, how do I want to test this? What does sum return on its own? Sum takes one positional argument. If sum is given an empty tuple, it returns 0. Okay, so that should be 0. And then quargs should be an empty dictionary because we called it with no arguments or keyword arguments. Does that make sense why I did that? Oh, let me close this.
It would pass an empty.
Yeah, so
and not
args,
just...
right. So args and quargs become empty tuples in dictionaries if no items are passed. And that means like we're, obviously when we call the function, we're still updating like call in our code, in our implementation here, right? We're still passing those in. They will just be empty. And so if we pass that empty value to sum, sum is going to return 0. And then quargs is just going to be an empty dictionary. So we're just making sure that if we call it for the first time and we pass no arguments whatsoever, then it's going to return a tuple that is 0 and an empty dictionary, which is what we would expect to be here if no arguments were passed, right? So now that we have that, we're going to have to call myfunc with some actual values. And so we will say myfunc 1, 2, verbose equals true. Oh, that's my fun. No. Okay, and then we'll say self.assert equal myfunc.calls. Why do you hate me? There we go. Myfunc.calls, this is the next one. And we'll say dot return value is equal to the sum of 1 and 2, which is, so that's a tuple, which will be 3. And then it'll be a dictionary where verbose is equal to true. Cool. And then I think we need to try with a error if we're testing an error. Have you guys seen how to test whether an error gets raised in Python unit test before? No? Okay. So they use this thing, the pattern is to use a context manager, which is that like with keyword that you generally use for opening files. And so you say with self.assert raises, and then we're going to pick an error that it's going to raise. In this case, we're going to say it's a type error because I'm going to make it trigger a type error right now. Self.assert raises type error, and then we'll call myfunc with 1 and then the string hello. And then we will say verbose equals true one more time, right? So some will have no idea what to do with these values, right? And I know it's a type error just because I've worked with sum a bunch, but if we pass the same values to sum in this REPL, then you get this type error int object is not iterable, right? Okay, so we've got that there. When you exit, if you're unfamiliar with context managers, the way that you define a context manager is by defining dunder enter and dunder exit. And so when you call with .self-assert raises, it calls dunder enter on the test case, which is something that like Python gives you. And then we run the function. And if it raises type error, or if it doesn't raise type error, then this will throw an error. And then when we exit when we exit this code block, so we go back to the dedenting to like normal indentation, then it runs dunder exit. The cool thing about this is context managers are awesome. They're one of my favorite things. The cool thing about this is this doesn't define a new scope. So we still have access to myfunc even after we've left the context, the context manager. Cool. So what we're going to say is self.assert is, so my func dot calls to dot return value is none, right? Because we didn't actually make it out of the function. Okay, and then this is where I'm going to leave a note here and say this is a problem, and I'll get into why here in a minute, and then we'll do self dot assert equal my func dot calls to dot exception, and that exception is going to be oh, hold on, as exception. There we go. And then we're going to say that the exception is going to equal, I spelled that wrong, exception. Okay. To make this make a little bit of sense, whatever exception is caught by self.assert raises will be defined as this exception. And because it doesn't define a new scope, this will be accessible even after we leave this code block, right? And what we're saying is we expect that the exception that is stored in myfunc's call list is going to be the same as the exception that we caught, right? So maybe you throw an exception, but it's the wrong exception. It might pass the test depending on how fragile the test is, but it's the wrong test that we're looking for, and they don't match across the board. So anyways, let's run this. We're going to fail the exception part of this because we're not doing anything with exception clauses at the moment.
You might want to also like comment out line 93.
Yep, you're good. Thank you. I appreciate that. Okay, so that fails because currently it's none, right? We didn't actually store the exception value anywhere. So let's talk about how to do that first, and then we'll talk about the last thing that we need to do. In order to catch this value, this code is kind of a mess, so I'm going to clean it up a little bit. We're going to get results. So we're going to say try. Okay, and then we're going to accept. And then this is going to be a pop quiz. We'll say wrapper dot, we'll say call dot exception equals E. So accept, well, fine. Exception as E. Call that exception as E, and then we'll re-raise the exception so that it still kind of exits. And we'll leave this here. Okay, this should be the whole implementation, but there is something I did that's very bad here. I just like to call it out when we're talking about managing things. So in Python, there is an exception hierarchy, right? It's an object-oriented language. Things inherit from other things. There is this exception, which is the big daddy Python exception, right? All exceptions inherit from exception, okay? Having said that, if you talk to Python developers, they will tell you, you never want to just catch exception, right? We want to catch something that's very general because we don't know what kind of exception will be thrown by the function we're decorating. It might be type error, it might be attribute error, it could be anything. We have no idea what the code is going to be. However, we don't want to catch exception because this will also catch if you like try to command or control C exit the program for any reason. That's also an exception. Or if your computer crashes, that's an exception. And oftentimes those are going to be handled very, very differently. That's not actually a failure of the function. That's the user telling your function to stop. So when you want to kind of catch all exceptions, but not the system exceptions, what you want to do is actually accept base exception. Okay? Base exception is what all of the errors you're used to seeing are caught by. So things like type error, attribute error. You can actually see this as a handy table. If you go Python exception hierarchy diagram, hey, built-in exceptions, base classes, blah, 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 blah. Stop iteration. There is a table. There we go. Here we go. Cool. Oh, I have that backwards. I'm very sorry. You do want to catch exception. You do not want to catch base exception. I had that backwards. So base exception includes things like system exit, so your terminal is actually closing. Keyboard interrupt, you actually tried to stop it manually with Control-C. Generator exit, which is I'm not going to get into. And then exception is all of these, like stop iteration or stop async error, stop assertion error, OS error, things like that. The reason that you generally don't want to handle base exception and do want to handle exception, sorry, I had that backwards. There we go. The reason you don't want to do that is because generally speaking, you don't re-raise the error, right? So like right here, even though raise is doing nothing, what raise with nothing does is it just allows the error that you caught to bubble up. So for example, if this is a type error, then it's gonna make type error the value of E. We're gonna say that the call object's exceptions should be that value, and then we're just gonna re-raise whatever specific exception E was, right? We don't have to write any like checking, we don't have to update a message. We could technically raise E, but this is a pattern that you see more often. So if you essentially want to catch any error, do something, but then let that error go through, this is the kind of the pattern of how you would do that. Is that making sense? Everyone with me so far? Okay. So then if we run this, this should actually work. Nope. Type error unsupported operand is not assert raises context object at 0, 1. Let me look at my notes real quick because I know I dealt with this. Let me see. I think maybe I'm confused. 1 second. Does that work? No. Call that exception equals E. I did this last night without testing it. Very sorry. Why is that not working the way that I expect it to? Let me look at my notes. Very sorry. Ah, ha ha ha.
Object. Right?
Yeah, I was
Yeah.
gonna say it's the actual unit. So, okay. I actually want this to be context, and then the context I want to be exception. And then that should work. Great. And if I change this back to exception to be a good Python citizen, that should also still work. Okay. Good eye. Yeah, I was actually calling the object that was returned by the assert raises and not the actual exception object. Okay. Now, why is none a problem here and here? I'll be honest and say none isn't a huge problem here for the exception, but it is a problem for the return value. Can you think about why? It's okay if you don't know. So let me ask this question in a different way. What do functions return by default?
None, I guess.
They return none. Yeah.
So it's not even necessary to put that, or
I mean, it's necessary to put it if we need to have a default value, because we don't have, if you look at our code, we don't have the return value. when we actually put args and kwargs into the call object, right? And the reason that that's necessary is because we don't know if this will actually evaluate. We might end up with an exception. And if we hit the exception and raise that error, if we have args and kwargs inside the try block, then like that code won't execute. It'll like freeze in place. There's all kinds of things that could go wrong, right?
So the none's for that then. Okay.
Yeah. So like the none is to make sure that we can instantiate the call object here without providing it return value, because we don't have that yet, right? Here's another problem with it. We don't know who's going to be like what function we're going to be decorating. What if none is a completely valid return value? Right? Like there could be all kinds of, if we're especially, this is more of a problem for our tests than anything, but if none is a perfectly valid valid return value, then our tests would break because we're currently checking for if something is none, right? As you can see, we can kind of pass all of our tests without doing this, but this is kind of a bonus. There is a thing that you'll see in Python every now and then called a sentinel value. And a sentinel value is, we'll say no return equals object. A sentinel value is a value that will is a value that is unique, right? So it gets placed into memory, and then it is itself. So you can say like no return is no return, and that will be correct. But if you say like, so let's do this here. We'll say no return is object, like that. And then let's say no return is object. That's false. And if we say no, if we say object is object, that's false. And if we say no return equals object, that's false. But no return does equal no return, and no return is no return, okay? This means that we, without having to do any work at all, we have created a completely unique value that only ever equals itself and only ever is itself. Every now and then, like for the most part, none is great. It's a perfect value to have as like a default argument. It's a perfectly valid like way of checking whether a value exists. But every now and then, for some problems, you actually need something that is more unique than none, because none can sometimes be a valid value for what you're looking for. And if you're actually checking that nothing has happened and not that the function has returned none, then you want to make sure that you have a value that can be actually unique. The fancy name for this is sentinel value, but ultimately you just think like truly unique value. So if we create this truly unique value, we say no return is equal to object, then we can actually say that the return value is no return, and that the exception value is no return. And those will then be completely unique values. None could be totally valid. It doesn't matter how they raise an exception or like what things are done. We end up, we have to change our code here a little bit. So the return value, I'm going to import things here. Please don't yell at me, Pep8. We'll say from record calls import no return. This is going to be one of those things where reading the tests is kind of important, because if you don't name your sentinel value no return, then the challenger will just fail. So that'll be something to document later. And so we'll say that the return value should be no return. And actually, I think it probably makes sense. Let's just say none for exception, because the exception is only going to be updated if an error happens. But and also an exception can never be none. So it kind of satisfies our unique value thing, right? So now we have this no return object, which means our function can actually return none. And we're tracking everything that we need to track. Now our class, or sorry, not our class, our function is actually like wrapping everything correctly. We're keeping our like name and docs and annotations thanks to func tool wraps. We have this inner function. We can decorate any function, and we have a list of history for what that function has done, what its return values are, et cetera, et cetera. If you wanted to visualize this a little bit, I'm just gonna copy that and then do this. We can say at record calls def add x int y int. This is an add function, return x plus y, like that. And then we can say add 2, 2. And if we do add dot calls, then look at that. The return value of that call was 4. The quargs are empty. The args are 2 and 2. If we do this, let's do 2 and 4, verbose equals true. Unexpected keyword argument verbose. Am I not taking quargs here? I am taking quargs here. That should not happen. Oh, it's because add doesn't take quargs. Ha, never mind. And then if we do add dot calls one more time. Oh, that's actually, I did not intend for that to be as cool as it was. So now we've got the exception for that call we did wrong. We've also got the return value, which is that no return object, right? We have the quargs we attempted to pass, and we have args 2 and 4, and then we fixed that, and we have the actual value we expect here. Pretty cool, huh? Right. Couple of hours. This is the kind of Python code that we did. With that, I am done taking your time. I'm going to stop sharing real quick. Does anyone need to copy this? Has everyone who wants it up to date? This will.
Are you gonna put this code somewhere that's shareable?
The challenge. So this is in the code challenges repo right now. I just haven't made any commits.
Okay.
I need to write up the README for this. The challenge code, like the tests and the README, will be up in the code challenges repo. If you'd like, I can put this code in a gist and just put that in like a general chat or something so that people can reference it.
Oh yeah, that'd be cool.
Yeah,
And
please,
also,
thank you.
once the video is uploaded, then people can come back and reference it as well.
Yeah, let me go to gist here, and then we'll do solution record calls solution.py. Repository. Okay, we'll save that. We'll create a secret gist. Save that, and then I will put that in Discord right now. Should that go in the code challenges repo or the code challenges channel?
Yeah.
Okay. Solution for the code challenge we did in our weekly meeting. Great. So there's the code if you need it. Let me stop sharing here. Cool.
Nick, thank you. I'm gonna stop the recording now.